So integration is the opposite of differentiation. Therefore, when you have to the rules for differentiating e to the x is e to the x, and it's equal differentiation that is also e to the x. So you rewrite it as the same. Therefore, when you're integrating e to the x, you will be rewriting the term as it is. And when you differentiate, you used to do multiply by the differentiation of the power. This time when you integrate, you divide by the differentiation of the power and plus c. So it's always is the reverse thinking of differentiation. So I'll give a few examples now. Every time we have the coefficient, we will just rewrite the coefficient because it's not in part of the integration. It's not going to change anything. So in here, when you integrate e to the 3x, again we said we're rewriting it the same first, and then we divide by the integration of the power plus c. Then we can simplify, and that's the final answer. Next one, you rewriting it the same, plus c, and divide by the differentiation of the power, which is 4. This one here, you will have to first rewriting it as an index format. So it's a third format, so you're rewriting it as an index format. Because we're rewriting it, we have not integrating it, so we rewrite the integration sign, dx, and now my expression is ready to be integrating it, is rewriting it first, divide by the differentiation of the power plus c. You can rewrite it as the rearrange and simplify, and that's the answer. This one here is the e in the denominator. As we remember before, when we do integration, we need to change it to the numerator first. So I'm going to rewriting it and changing it to negative power, and now my expression is ready to be integrating. So you will rewrite it and divide by the differentiation of the power. Simplify, you'll end up with negative 1 over 5 e to the power of 2x plus c. This one here is index search format. So first we're going to rewrite it as a index format, and then changing it to the numerator, move it to the numerator here by changing the sign of the power, and now is ready to be integrated. So you rewrite it again, divide by the differentiation of the power, and now rearrange. It will be negative 18 over cubic root of e to the power of x. There's no space, plus c. You can leave it at this format, it doesn't matter if it's just integrating and not simplifying. And that's the lesson. For the next one here is you can see we'll have to expand first because there is no product rule, so we're going to expand first. When we expand, we add the powers to the same base, and now it's ready to be integrated. The next one is a rational expression, and because there's only one x and one term of x in the denominator, so we can do split fractions. So we're going to split fractions, and now we're going to simplify each fraction by minusing powers. 2x minus 3x is negative x, and now it's ready to be integrated. So we remove the integration sign, rewrite it, divide by the differentiation of the power. Rewriting the e, divide by the differentiation of the power, plus c. You can rewrite it as a positive power. And that's done. The next one is e to the power of x is the base, where it's the base is the e. So e is just a number, okay, but it's a special number, so we give it the variable e to represent it. But it's a special number, so it's a fixed, sorry, it's a constant, so it's a number. So therefore, 2 to the power of x or 3 to the power of any other number to the power of x, we're going to redo it. We're going to integrate it exactly the same way. So the integration of e2 to the x is rewriting it, but this time we're going to divide by ln 2, okay, and the differentiation of the power is just 1 plus c. So this one here, integration is rewriting it, divide by ln 3 times the differentiation of the power, which is 2, plus c. So you could rewrite that. It's always the number before the ln. And this one here, again, you're going to rewriting it, divide by the differentiation of the power, which is -1 times ln 10, plus c. So it's exactly the same as the e. You rewrite it, divide by the differentiation of the power, but the only difference here, you're going to divide by ln the base. The e, we didn't do ln e because ln e is just 1. Okay, so all the integration questions that we've done before, we do plus c because we don't have other piece of information in the question to be able to find the value of c. So this time we've been given a piece of information. We've been given the double differentiation function. We've been given the value of the f when you substitute x is 0, and you've been given the value of the f when you're substituting ln 2. So we need to get to f to x. So we will integrate first to get f dash to x. With respect to x, so we're integrating that. So that's f dash to x. So now we get f to x by integrating this with respect to x. So we're rewriting it, dividing it by 2, so that's why we'll end up with e to x plus cx plus k. So we got this equation here. Now we're going to substitute the different values of x to give the value of y. So we have the value of f to x is 2 when you substitute x is 0, and that's anything to the power of 0 is 1, so therefore 2 1 plus k, so k is equal to 1. And now you're going to substitute, instead of f to x is 5 plus ln 8 equal e to the power of ln 2 times ln 2 plus c open bracket ln 2 plus 1. Now we're gonna rearrange. So to find the value of c, so I'm gonna leave c ln 2 on one side and taking everything to the other side. And now we're going to simplify this further. 5 minus it's 4. Ln 8, I can write it to ln 2 to the power of 3. So therefore I can write it as 3 ln 2 minus e to ln 2. And now we can even simplify this further by having ln 2 equal 4 plus 3 ln 2. E to the power of 2 ln 2 is 4, because the e and ln will be cancelled out. It's giving me 1, and that's 4, so it's minus 4. Those two will cancel out. Therefore, c is equal 3 ln 2 divided by ln 2. Those two will cancel out. C is 3. So your final function of x is e to the power of 2x plus 3x plus 1.